Hey class. You got your final assignment, and I lay out there a couple different ways that you can influence your facades with attractors. We've already covered solar, but I wanted to cover real quick point attractors. They're very simple in Dynamo, much less complex than the solar. So we'll get right into it. So I have opened the conceptual mass that we used in the solar script, and then I'll just open up Dynamo, and you can open up the solar script that we built. That'll be a good starting point. It's basically the same idea as the solar script. You use the same basic functionality in setting it up. So gotta go in and make sure here. Let me make sure that the face is selected, and then make sure that these are all right. Okay, so if we hit run, take a second. We have our adaptive component in there already, and we have our solar script in there. So we get a nice, attractor script based on the sun position. But if we want to do a point attractor, let's go in and just delete all the stuff that has to do with the solar. And you obviously should save as, so you don't overwrite this, which actually I'll do right now. So we can delete that guy. And we can delete the normal since we're basically what we're going to do is we're going to place a point on the face of the mass, and then use that point, calculate the distance between it and all the panels, and use that distance in the same remapping tool to influence our NCP parameter. So to get started, right? So if we hit run again, what is this? The best overload. Blah, 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 blah. Here, let's go in. I find it's always good to delete what's already created in there. And it doesn't have anything to actually influence because it's not getting any input here. So that's why it's erroring out. Deleted those panels. So let's go in and type in point, and then we can scroll down. Maybe it's not on here. Type in face. Select point. Yes, there it is. Select point on face. And then this tool allows you to literally just select a point, any point on a face of a mass. So if you just select and hit run, you can see that it's placed a point on the face of the mass. And if we unpreview the surface offset, you can also see it here. So what to do with that? So we want to take this point and measure the distance between it and all of the center points of the panels. So we can do that by distance geometry, or geometry distance. Once again, I hate Dynamos. There we go, distance 2. So distance 2 geometry. So this is asking for geometry to measure between. So we'll take the polygon center, plug that into the geometry, and then select the point that we just created on the face, plug that into other, hit run, and then it's going to give us 41 distances to match the 41 points that we created or are referencing. All right. So now all we have to do is go in, plug the distances into the list minimum, the list maximum, and the input value for the math map 2, and hit run. And it doesn't like me. Does it not have the family loaded? There we go. All right, and now, as you can see, we have our panels being influenced by the point that was on, that we placed on the facade. And if we go in and select point on face and plug it in over here and hit run, our panels then adjust and adapt to it. All right, so real easy, real simple. I think this will probably be the easiest thing to do on your scripts for your final project. But, the solar is a pretty good one as well, just because, that actually has real world consequence, where the point on the facade is really more of an aesthetic choice. But if you have any questions, let me know.